So one of my favorite types of questions, this is designed to get you thinking about different structures as well as practicing naming and so on. So isomers of pentanol. Well, we got 5 carbons. Let's think about the ones that have just a 5 carbon chain. So in other words, some kind of pentanol. Obviously, we can put the 1 on the end, so pentan 1-ol. We can put it on the number 2, so pentan 2-ol. We can put it on the number 3, pentan 3-ol. Now, if we were to put it on 4, that would be the same as 2, of course. Now, let's make sure we see that this is a primary one, because the carbon to which this is attached only has 1 other carbon on it. This is a secondary one, because the carbon to which it's attached has 2 carbons. And this also is a secondary one, because the carbon to which it's attached also bonds to 2 carbons. Now, always, always, always keep in the back of your mind, or the middle of your mind, or even the front of your mind, the idea that when you've got structures that have lots and lots of carbons in there with just single bonds, you can have enantiomers, you can have chiral or stereogenic, as the right word is, carbons in there. So if we look at pentan 1-ol, none of these have got 4 different groups on them. That's got 3 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, and 2 hydrogens. When we go up here for the pentan 3-ol, we got 3 hydrogens on the 2 end ones, and then 2 hydrogens on this C2 and C4, 1 hydrogen on C3, but C3 as well as that 1 hydrogen and an OH also has 2 effectively ethyl groups attached to it. So therefore neither pentan 1-ol nor pentan 3-ol contains a chiral or stereogenic carbon. When we get to pentan 2-ol, however, 2 end ones got 3 hydrogens, 2 hydrogens, 2 hydrogens, and now carbon 2 here has got an OH, it's got a hydrogen, it's got effectively a methyl and a propyl group on it. So 4 different things on C2, which means that there is the possibility of enantiomers. So in order to define and really express properly enantiomers, you need to start thinking about drawing in 3 dimensions. So first of all, let's make sure we know what's on there. Let's assign priorities. So the OH is always going to be priority 1 when you've got carbon, carbon, hydrogen. Hydrogen priority 4. Now of the 2 carbon groups, the methyl carbon only bonds to 3 other hydrogens. The propyl carbon bonds to 2 hydrogens and another carbon. So this has the 2nd priority, and the methyl group has the 3rd priority. Now let's draw it so that we've got the hydrogen at the back. If you put the hydrogen at the back, it always makes it much, much, much easier to assign the priorities. So here I'll just have the hydrogen at the back, the OH there, the methyl there, and then this nice long propyl chain there. Now if I draw the mirror image, so all I've done here is I've started here and then drawn backwards. So there's the propyl going to the carbon there. The OH stays the same. The H is back and the CH3 is forward. H is back and CH3 is forward. But just the very act of inverting the carbon, so to speak, by which side I put the propyl on, now gives me this mirror image, which means I've drawn the enantiomers. So let's assign them. First one here, the OH is 1, then 2, then 3, then 4. So I had to go clockwise, which makes this R. And then here I go 1, 2, 3. So here I'm going anti-clockwise. So that's the S. So there are a total of 4 isomers, that's including structural and enantiomers, excuse me, that are based on 5 carbon chains. Okay, and of those we have 1 primary and 1, 2, 3 secondary. Now let's explore the 4 carbon chains. So these are going to be something to do with butanols. Okay, well obviously first thing I can do is draw my 4 carbon chain, and I can put the 5th carbon coming off here as a methyl group, and then I can start sticking on my OHs. So this one here, I've put the OH on the end on carbon 1, which makes this methyl group on carbon 2. Or I can put the OH on the end again, but now move the methyl along so it becomes on carbon 3. So we've got 2 methyl butan 1-ol, 3 methyl butan 1-ol. Okay, if I was to stick the methyl group elsewhere, so for example if I stuck it on here at what was going to be carbon 4, well that now just becomes pentan 1-ol. And if I was to stick it on here, carbon 1, well that would just, so no methyl group there, but putting the methyl group there, that would just be pentan 2-ol. Okay, so as far as the butane 1-ol possibilities go, 2-methyl or 3-methyl. Now again, let's think about the enantiomer possibilities. I won't go through it all, but there's no stereogenic or chiral carbon in 3-methyl butane 1-ol. But if we look here, put a hydrogen there, then this carbon 2 has got a methyl group, an ethyl group, a hydrogen, and then this CH2OH group. So this one is a stereogenic carbon. Let's assign that as ethyl just to make it easier to write. So one way to do it is to put CH3, the CH2OH, the ethyl and the hydrogen there. Let's do the mirror image of that like that. So now it's the OH here that I've inverted, keeping the CH3, the ethyl and the hydrogen the same. Now let's think about priorities here. This is a CH2O. This is a CH2C, and this is just a CH3. So priorities 1, 2, 3. So this one's going to be the R, and then 1, 2, 3. So this one's going to be the S. Now, how about other possible butanols? Well, we've done the butane 1-ols, so now let's think about butane 2-ols. Okay, so the first possibility is our 1, 2, 3, 4 butane. Let's put the OH on the 2 carbon and put the methyl on there as well. So now that gives us the 2-methyl butane 2-ol. And then again, keeping the OH on carbon 2, put the methyl on carbon 3. Now I've got 3-methyl butane 2-ol. Again, let's think about the stereogenic possibilities. Nothing here, but here we've got a carbon right there that has a OH, methyl, this isopropyl group here, recognizing this as an isopropyl group for those of you who like the older way of naming things, and of course you do need to be familiar with that. And then there's the hydrogen there. So 4 groups here on carbon 2, drawing them out in the usual way. Now as far as priority goes, again, oxygen going to be number 1. This carbon that has 2 carbons on it, the isopropyl, is number 2, methyl number 3. So 1, 2, 3, we're going anti-clockwise, so that's the S, and here we go 1, 2, 3, so that's clockwise, that's R. Let's look at primary, secondary type things. So in this case, the OH is the 1-ol is primary, 1-ol is primary, so we've got 1, 2, 3 primaries there. So on here, the 2-methyl butane 2-ol, carbon 2 there is a tertiary carbon. It's got the OH on it, but also bonded to 1, 2, 3 other carbons. So that's our first tertiary, and indeed the only tertiary we have to worry about. And now the 3-methyl butane 2-ol is a secondary one. So we've got 1, 2, 3 primaries, 2 secondaries, and a tertiary. Finally, let's see if there's one that has 3 carbons, and the only real possibility here that we haven't already drawn, there's the prop chain with the OH at the end and 2 methyl groups there. Counting them up, we got 1, 2, 3, 4, 5 primaries, 1, 2, 3, 4, 5 secondaries, and 1 tertiary. Fun questions.